This is the lesson for Algebra for 2-4, day 2. So yesterday we worked on graphing compound inequalities, where you graph two inequalities on the same number line, and statements went in towards each other and formed a solid bar across, or statements go out and have the arrows going out. So today what we're going to do is we're going to solve a compound inequality and then graph it. The weird thing about these solving inequalities is when it's a and statement, like 4a is on your screen, you are solving two inequalities at the same time. So the goal when you're solving any inequality is to get the letter all by itself. To get that letter all by itself, there's really two inequalities here. We really have 6 is less than x minus 6. But then we also have x minus 6 is less than or equal to 9. So we smush these two inequalities together to give you this and statement. And we're actually going to be solving that at the same time. Well, if we take a look at both the red inequality and the blue one, if you're going to solve these, you would do the same thing to both things. You would try and get the x all by itself. So we'd have to do plus 6 and plus 6. Well, we're actually going to solve them at the same time. So what you're going to do is to try and get that x all by itself, we would get rid of this minus 6 by doing plus 6 and plus 6 and plus 6. We're sort of solving two inequalities at the same time. These 6's cancel out in the middle. So bring your numbers straight down. 6 plus 6 is 12. Bring down our inequality sign. We're just left with an x in the middle. Bring down our inequality sign. 9 plus 6 is 15. So in order to get that x all by itself, we had to get rid of that minus 6. Well, normally whatever you do to one side of the equal sign or inequality sign, you have to do it to the other side. Well, because we have 2, we had to do it twice. So plus 6 and plus 6 to solve it at the same time. When we go to graph this, we would have a 12 and a 15. They're coming together in the middle because it's an and statement. We have an open dot at the 12, and we have a closed dot because of the or equal to sign, and they come together in the middle. Now, this next one gets a little bit more complicated. There's really a 1 in front of this x, so that's really -1 times x. The opposite of times is to divide. So we would divide by -1, divide by -1, divide by -1. Again, whatever you do to one side of the equal sign or inequality sign, you have to do to the other. These cancel out. So we have an x in the middle. Now, you have to remember the rule. When you multiply or divide by a negative number, you have to flip the sign. So we're dividing by -1 and by -1. That means we are going to flip both of those signs. -2 divided by -1 is 2, because a negative divided by a negative is a positive. 6 divided by -1 is -6. Now, we can't leave our answer like this. If you think back to yesterday's lesson, just like this example was, you have to have both of the signs in a compound and statement. They both have to be less than symbols. So we really need to flip around this whole thing. Also, this is written backwards because remember, we always want our smallest number to the left and our bigger number to the right. So we're actually going to take this and flip around the whole thing. So we're going to flip around the number, the -6 to the beginning. We need to flip the sign because we're flipping around the order. The x stays in the middle. We're flipping the sign and we're moving that 2 to the end. So this is really our answer because we always need that smallest number all the way over to the left, and we need the less than symbols in an and statement. So -6 would go here, 2 would go here. We would have an open dot, and they would come together in the middle because it is an and statement. When you have a one like this, again, this is really two-step inequalities that we're solving. So in order to get the -3x all by itself, we would have to do -1, -1, -1, because that way we get that -3x all by itself. So the -3x is all by itself in the middle. We're just subtracting by 1, so we can just bring down our inequality signs. We don't have to worry about flipping it. Remember, we only flip it if we divide by a negative or we multiply by a negative. -1 minus, or sorry, -4 minus 1 is -5. 12 minus 1 is 11. Now we have -3 times x. Well, the opposite of times is to divide. So we want to divide by -3, divide by -3, divide by -3. So that way we get the x all by itself in the middle. Now we are dividing by negatives, so we need to flip the signs. -5 divided by -3 is positive 1.6 repeating. -11 divided by 3 is -3.6 repeating. Now, when you take a look at that, that's written backwards, just like the previous example. Remember, we always want our smallest number all the way over to the left and our biggest number all the way over to the right. Our x stays in the middle. When you flip around the order, you have to flip the signs as well. Remember, we want less than symbols. So this is what we would be having as our answer. We'd have a -3.6 repeating here. That's going to be a closed dot because of the or equal to sign, and a 1.6 repeating here, closed dot because of the or equal to sign, and they come together in the middle. So that's how you do and statements. Or statements are a little bit different. Or statements, you're solving two completely different inequalities. So I could draw a line right through the or, and I'm solving two completely different inequalities. You're not solving them at the same time now. So we have 1 plus 6x is greater than 11. -1 minus 1 to get that 6x all by itself. Divide by 6, divide by 6. X equals, this ends up being 1.6 repeating. So it's not equals though, sorry, it's not equals. We have an inequality symbol, so it would be x is greater than 1.6 repeating. We don't need to flip the sign. We divided by a positive. You only flip the sign when you divide by a negative. So we have this as one of our inequalities. On the other side, we want to get that x all by itself, so we want to do +4 and +4. -5 plus 4 is -1. We don't need to flip the sign. So now we have two inequality statements. To make our final answer, remember, we always want the smaller number to come first in our inequality statement. So I'm just going to take my answer and put it up here. We want this one to come first. X is less than -1. Or, now why am I using the or? I'm using the or because there's an or in our question. And then it's x is greater than 1.6 repeating. So how would you graph that? So we would have the -1 here, which is our smaller number, 1.6 repeating here, which is our bigger number. X is less than -1. So we would have an open dot and the arrow goes out. Remember, in or statements, the arrows go out. And then we have x is greater than 1.6 repeating. Again, that would be an open dot and the arrow would go out. So that's what our answer would look like. Take a look at a couple more. In a statement like this, all right, you could pause the video and try this one on your own if you wanted to. So we want to try and get this 2x all by itself. You would have to do -2, -2, and -2 so that those cancel out. Bring down our 2x, bring down our inequality signs. 4 minus 2 is 2, 12 minus 2 is 6. Now we have 2 times x. The opposite of times is divide. So divide by 2, divide by 2, divide by 2. That gets that x all by itself. We're dividing by positive numbers, so I know my symbols are just going to stay the same. 2 divided by 2 is 1. 6 divided by 2 is 3. So there is our answer. We would have a 1. We'd have a 3. We'd have a closed dot because of the or equal to symbol at the 1. We'd have an open dot at the 3 because there is no or equal to symbol. And the 2 dots are connected in the middle. Let's try one more. Here we have an or statement. We draw a line down the middle because we're solving two completely different problems. -5 and -5 to get the x all by itself. So we'd have x is greater than 9. Here we have divided by 3 and divided by 3 to get the x all by itself. So we'd have x is less than 3. Now, notice that our bigger number is towards the left and our smaller number is towards the right. We always want our smaller number to come first. So when I would go to write my final answer, I would write x is less than 3, or, notice that I'm just bringing down the or, x is greater than 9.
So I'd have a 3, I'd have a 9, I'd have an open dot at the 3, arrow going out. I'd have an open dot at the 9, arrow going out. So remember, ands come together in the middle, ors go out. If it's an and statement, you're going to solve both inequalities at the same time. If you're going to do or statements, you're going to solve them each individually. All right. Don't forget to flip your sign if you multiply or divide by a negative. Always remember the smaller number in your final answer, your smaller number is over to the left, your bigger number is over to the right.